Today we're going to be doing a drone survey using AeroPoints by Propeller, and I'm going to show you the entire process of collecting data and processing it online using Propeller's processing engine. Now these AeroPoints utilize post-processing kinematic or PPK corrections in order to give us coordinates of their position so that we can use them for control in our survey. Now to do PPK corrections, you are going to need a base station. You could use Propeller's network corrections, so you would use all of your AeroPoints as ground control points, or you can use one of these AeroPoints as a base station for a short line correction for your drone and other AeroPoints. Or if you have a known point, you can set up your own base station with a tripod and tri-brac and use that as the base station for corrections for the other AeroPoints and your drone. All right, so this is our base point. We've already got coordinates here, and we're going to be setting up our base station to observe it for our PPK corrections. And you want to set this up at a relatively higher point, something like this. I'm going to put this over the point. There we go. Sink this tripod to the ground. And I'm going to do some adjusting here to keep us over the point. And now that I've set up the base station, we'll go ahead and power it on. Now, the main purpose of the base station is it's going to allow us to do PPK corrections for the entire project. Now this isn't necessary because we are using AeroPoints that do PPK on their own. But if you have a known point like we do here on this site, we can set up our base station and run a short baseline so that we can do our corrections here locally to this base station rather than using network corrections or using the PPK corrections that we get from the AeroPoints. All right, so I'm gonna launch the Imlid Flow app. We're gonna search for our base station. Okay, so I've got Imlid Flow loaded here and I can see my reach base, so I'm gonna connect to it. And under the base settings, I'm going to choose a point, and here is our base point that we measured. So I'll use this as our coordinates. Our antenna height, I measured this to be 1.45 meters. Save, everything looks good, so I'll hit save here. All right, we'll go back. I'll go over to logging. And in logging, I'm going to select start recording. Now this is logging data, so we're going to have a Rhinex file, and the one that we're looking for is the observation file, because that is what we're going to use as a solution for our processing on Propeller. Now again, you don't have to do this, but this is one method of getting PPK corrections. All right, let's go and set up our first AeroPoint. All right, so I've got the first AeroPoint. I'm gonna set it here so that the open sky makes it very visible when we see it with the drone. That way, if we ever try to do any georeferencing, we can clearly see where the center of the target is. So I'm just gonna set it right there. So because I'm all about accuracy, I'm actually going to measure this using my GNSS receiver so that we can compare the coordinates after the PPK corrections are complete to what I measured with my GNSS receiver. You don't actually have to do this, like this is not a part of the workflow, but I just wanted to check the accuracy, so I'm measuring this in two different ways.
If you're interested in learning more about surveying and geospatial technology, then enroll into thesurveyschool.com, where you'll have access to accelerated courses and our exclusive survey community.
All right, so we just measured it with the GNSS receiver, and to power on the AeroPoint, all you have to do is press this little power button, and then the logging light will go green. So we just leave this target alone, we don't touch it. It's going to log its position and then eventually take that log information to be processed for corrections. So now we're all set with this AeroPoint. Let's head down to the other side of the park where we will set the other two AeroPoints. All right, and I think that this is a good spot to set the next AeroPoint. So I'm gonna set this AeroPoint here. It's important to note that when you're setting up the AeroPoints, you want to spread them out. You don't want to cluster them all in one spot. So I've got 3 AeroPoints, so I'm going to try to put them on the outsides of the project. If you've got 5 or more AeroPoints, then consider putting a couple in the middle. So you have majority on the outside, a few in the middle. That way you've got the best coverage for your site. Just for reference, you know, Propeller recommends that you have 1 AeroPoint per 100 acres. Of course, you can have more, but as a minimum, you want to have at least 1 per 100 acres. So I think this site is under 100, so we should be good. All right, and we're just gonna measure again the center of this target for our own information, just so we have another way of getting the coordinates. All right, I'm gonna go ahead and measure the coordinates here. Okay, now I'm gonna press the power button and we're gonna start logging data. All right, one more target. Let's go ahead and set it. All right, and I think this here is a good spot right before we get to the trees, where we're gonna set our last arrow point. Take a quick measurement of the arrow point. Okay, perfect. And again, I wanna emphasize this. What I just did here is not a part of the workflow. This is just me checking the accuracy of the arrow point after it's processed its coordinates. So this right here, this is all extra. You don't have to do this. All you have to do is press the power button and start logging data. All right, now that we've set up all of these arrow points, let's set up our drone so we can fly this mission. Let's go ahead and set up the drone. Do this one first. Put our RTK module up top. Make sure we got an SD card here. Yes, we do. Put a new battery in here. No power on the drone. Okay, so I've got the DJI Pilot 2 app opened. I'm gonna start by going to flight route, and we're going to create a new route, and I'm going to select area route. Okay, we've got our satellite map, and I'm going to start by drawing the polyline for our site. So we're gonna fly here, go all the way over here, come up here, and all the way here. All right, this looks good. Actually, let's go here and then here. All right, perfect. So here is our area that we're going to fly. And I'm going to now go through the different settings for the drone. So Mavic 3 Enterprise, M3E, okay. We're doing an ortho collection. And we're probably gonna fly this, I would say, around 100 feet above ground level. That should clear everything. 100 foot? No, that's the only thing I'm a little concerned with. I don't see this. Oh, yeah, here it is. Is that thing 100 foot or not? I don't know. We're gonna fly over there and find out. It's the only way we're gonna know. As much as I'd like to preserve the battery, but I also like to preserve the drone. All right, we're getting closer. Oh yeah, that thing's way above 100. Like I'm at 115 right now and I'm about to crash into it. So, let's see if I go to 130. How are we looking at 130? I think I would try to go a little bit higher. Yeah, 150, that's definitely the right height. So let's fly back. Always want to double check, because you never want to be put in a position where you're flying right next to an object. You might crash into it. It'll throw off your whole project. So just take the extra time and figure out what the highest object is on the site. So I'm gonna raise this up to 150, and we're gonna go to the advanced settings. I like to do 80% overlap and side lap. And then with the arrow points, you wanna make sure your flight is a minimum of 10 minutes long. This is right now sitting at 8 minutes, flying at max speed. I think the easiest way to do it is to just slow down your drone. You're gonna get better imagery, even though you have a mechanical shutter, but it's still just better practice to fly slower when you can. And in this situation, we actually have to fly slower. So I'm gonna just bring this down to, I don't know, let's say 15 miles an hour. So now we're at 14 minutes. You can go a little bit faster. Let's say 16 miles per hour. So now we're flying just under 13 minutes. So that looks pretty good. We're gonna switch the photo mode over to distance interval. Okay, I like everything I see here. We'll go back. All these settings look good to me. If we look at our RTK, we've got a strong connection for our RTK, so all our satellites are there. And then we're also gonna run PPK on these images inside of Propeller, so it'll have double correction, so we should be really good on our drone's trajectories. Okay, I'll hit the save button, upload the mission. All right, I've uploaded the mission, so now let's start flying. Here it goes. And it's gonna head over here to the southwest corner of the site. And it should pop itself into nadir. And there it goes, it's collecting images. And it looks like our RTK may be floating, but again, that's okay because we are going to be processing everything in PPK. So regardless, we'll have corrections for our trajectories. Looking good here. It looks like our RTK is back. Flying around that, looks like that cell tower. Doing another flight line. There it goes. We're about a third of the way there. You can see kind of the targets in the imagery. They're coming out quite nicely. Nice and clear, big targets. And so while the drone is flying in the air, I wanted to let you guys know that I'm going to be attending the Commercial UAV Expo happening on September 3rd to the 5th in Las Vegas, Nevada. Commercial UAV Expo is one of the largest drone expos in the world, showcasing the latest in drone hardware, software, and sensor integration. If you're looking to collaborate with industry leaders in the UAV industry, or if you want to sit in on formal presentations, then be sure to use promo code RAMI100 to receive $100 off of an exhibit hall pass or a full conference pass. I'm going to be there filming several videos for the conference, and so if you're a business that has a booth in the exhibit hall, definitely reach out at rami.promo, where you can reserve your spot in one of these videos to promote your business and have your exhibit booth live on forever. Check out the link in the description, and I look forward to seeing you in Vegas for Commercial UAV Expo. All right, and it's gonna come home now. There it is, right above us. Back it up. All right, looking good. All right, now that we're done flying the drone, we're going to be picking up all of the AeroPoints. Now, it's recommended that you pick them up in reverse order. So the one that we set here in the southeast corner, we're gonna pick that one up. That's the one by the giant tower. And then we're gonna go around and pick up the first one that we set in the northwest corner, and then everything will be logged in our phone using the AeroPoint app. Let's go to the first target. Okay, so we're approaching the first target. And I've got the AeroPoints app here, so I'm going to load it. And it's gonna start searching for this arrow target, and it looks like it found it. Yep, there it is. It's been logging for an hour, so that looks good. We'll tap on it. So I can look at the conditions of this target, how it's performing. Looks like everything is good here. Yeah, no issues. So we'll go back. And what I'm gonna do is tap on the power button, and that'll end the session and start to upload the data to my phone. All right, now it's uploading the Rhinax files from this target to my phone, and then it'll be uploaded into the Propeller system online so that once we process the data, everything will be there. And it's not a big file, it's 2 megabytes, so pretty easy. All right, perfect. So that's all set. If I look at my target here, yeah, it's turned off. So I can now remove it, and we can head over to the next AeroPoint. I hope it's turned off. Yeah, it's turned off. Okay, it looks like we're approaching the next target. This looks good. I'm gonna click search again, and it's gonna look for this arrow point. There it is. Looks nice. Checking up on it, everything looks healthy, looks good. Can't complain. All right, go ahead and stop. And what it's doing is it's looking for my phone's hotspot. So that's how it's getting its internet connection, and everything is uploaded automatically. So there it is. And just like the last one, uploading the data to Propeller. All right, we're at 66, 69, 72%. All right, perfect. Hit dismiss. Looks like, yep, that one's good. So we can pick it up. I like to carry these where I put the backs of them to each other like this. And then you can carry them and head over to our third target. And we're at the last point here. I'm gonna go ahead and press upload, and it's gonna search for my phone. All right, looks like I found it. And now it's going to upload the data. Perfect, we're all set. All right, and now that we've finished collecting data with the drones and we've picked up all of our arrow points, we are going to end the session here with the base station. Over on the Imlet Flow app, I'm gonna go to logging. And there we go, we've been going for about almost 3 hours. I'll hit stop. All right, now it's going to compress all of the Rhinox data that it collected. All right, now that we're done collecting data using the arrow points, let's head inside and process everything on Propeller. All right, now we have all of our data, and so you're gonna visit propelleraero.com. I've left the link in the description for you, and this is going to be the home page. It shows you kind of what the online processing looks like, and you'll just come up to log in, and then in log in, you're gonna put in your credentials and sign into your account. Once you're in, you'll be inside of your Propeller portal. And this is where you're going to find all of your sites and projects that you've worked on and where you're going to start a new project. So for us, we're gonna come up here to the top where it says create new and select a new site. So for us, the name of the park was McKinley Barrier Free Park. And then it's asking us what kind of project this is. For us, this is a construction project, and what other industries are involved in this. And for us, we are selecting surveying. We'll say next. It'll then ask us to locate the project. So I'm just going to zoom in here and get as close as I can. So here I'll just put in the name of the site. Okay, and here is our site. So that looks good. We'll say next. So all this is just the thumbnail for your site. So when you go in to see your, the sites that you've worked on, you'll see that one for your project. Okay, next it's asking us about our coordinate system. I want to use a published system. I've selected NAD 83, Michigan South. And then for the vertical datum, I want to do NAVD 88 using geoid 18. So looking here, I can see this one right here is geoid 18. And then for the units, we are in Michigan, so we use international feet here. So I'm gonna select international foot. And then it'll ask me if I wanna invite anybody to join me in this project. So if I work for a larger company and I've got employees that work with me, I can invite them to this link so that they can see the project, and then I can give them certain permissions, whether or not they can edit the data or just view it. I will just skip this for now. And now I need to upload the data. So I'll click on upload data. All right, so the first thing is the survey itself, and these are all of the images that we collected with the drone. If I had a point cloud that was pre-existing, I could select the point cloud option here, as well as other data that may have already been processed. But again, we just flew this site. We don't have any actual processed data, just raw images. So we'll stick to survey and we'll say next. And then it'll ask us which type of corrections we would like to use. So you could use the Propeller PPK corrections, which would take your images and correct them if there are no corrections on them. So let's say you were flying a drone that doesn't have RTK, or you lost your RTK for a substantial amount of time, then it could do that for you. Or you can just upload the images, and if you trust the geotags that are on the images, it'll just use those positions. So I'll go ahead and use the Propeller PPK. I have nothing to lose by adding an additional layer of corrections to my data. And we'll say next, and then we'll add our images. That's the folder, open. I'll just select it all and drop it all into the project. And you can take a look and see, yep, there's everything. It's coming in nicely, very good. And if we look at the file validation, everything is checking out, everything looks good. So this tells us that everything was done correctly in the field, and we shouldn't have any issues processing the data with Propeller. I'm gonna say next. It's gonna ask us when we did the survey, so this date and time looks correct. So we'll say next. And then it's gonna ask us about our ground control points and checkpoints. So since we use these arrow points, we will select arrow points. But let's say we had additional ground control points, ones that we set with just vinyl targets. I could add in a CSV file, and that'll allow us to use both the arrow points as well as the traditional ground control points. We didn't do that, we just used the arrow points for this project, so I will stick to arrow points. All right, down here we have coordinate system again, making sure that everything matches, so these two look good. And then it's gonna ask us which arrow point file we want. So I want the last one we did. And there we go, we can see all 3 arrow points. And it's important to note, again, that you spread out your arrow points. So for us, we spread them out like this. We didn't cluster any of them next to each other. So this is a healthy spread for the arrow points. Now I mentioned that there are 3 correction methods. The first one is the propeller correction network. And this will basically correct your arrow points based off of the core stations that are placed around your area. So looking here in Michigan, we've got a ton of coverage. So where our site is, we would definitely get corrections using the propeller correction network. The other option is using a global survey benchmark. This basically takes one of the arrow points that you set and uses it as the base station. Now you would have to provide the coordinates of where that arrow point was placed. So let's say you placed it over a known point that you have, you could use that arrow point. So this is really good if you've got a disposable amount of arrow points. That way you can use one of them as a base station. But for us, because we only had 3, I used my own base station and I set it up on a tripod over a known point. And that brings us to option number 3, uploading a Rhinex file. And this is the file that comes out of my base station. And so I'm gonna use this method, but don't feel pressured like you have to go buy a base station. You could totally use the correction network, or you could use one of your arrow points as a base station. So I'll select files, and we'll come over to the reach base raw data. And then this right here is the observation file. I'll say open, and here we go, everything looks good. And now it's important to mention that the period of time where the Rhinex file was observing data, it has to start before and end after your survey. So for us, it definitely started before and ended after. So that tells us that our data will be corrected since the time intervals will match, and we had Rhinex data for us to correct our survey. Next, it's gonna ask us for the coordinates of our base station. So I'll go ahead and add that information in now. All right, looking good. This all looks fantastic. I like it. I'm gonna hit save. All right, now we've updated our ground control points, and you can see all 3 arrow points are used as ground control points. Again, if you have a disposable amount of arrow points, you can use some of them as checkpoints. You don't have to have them influence the data. I only have 3, so I'm gonna use all of them as ground control points. If I have any comments here that I wanna put in, I can add it in this section. For me, everything looks good, so I'll say next. So now I can select filters, and the no filter option will leave the data as is. It won't change anything, it won't remove anything. The equipment filter will remove vehicles, trucks, man-made objects, so that way it clears up that from the data, and that can give you a cleaner output. Some of the more advanced filters include vegetation, structures, and you could select everything and get just a bare earth model. So I'm just going to select equipment. I don't really care to get everything removed, but I do want to see just what a little bit of filtering could look like. And this is what I can expect from Propeller once all the processing is completed. I'm gonna have an ortho image, a DEM, a point cloud, a 3D mesh. I'll make sure to turn that on, as well as a DXF file with a tin model. So we'll say next. Here's some more project details just to ensure that I've got everything correct. We then have the quality assurance guide. So the stricter the QA, the more effort we will go through to troubleshoot issues. This may take more time. So I like to set this to moderate, but you could put it at lenient if you trust your work. I don't think you should skip it. I think you should allow Propeller to kind of go through your data and make sure that it's done correctly. You know, depending on how well you trust the data collected should dictate how strict you are with your quality assurance. Okay, I'm happy with all of this. So all I have to do now is click submit. And now it's uploading everything into the Propeller system. And then before long here, we should be all set. There we go, we are uploading, and we need about 6 minutes until all of the data is uploaded. 100%, all right. All right, perfect. So now it says your data set has been submitted to the Propeller data team. You should expect your data to be delivered within 24 hours. You can track the processing of this data set using the data processing dropdown. And that's it. You've now uploaded all of your data into Propeller. We'll come back in roughly 24 hours to view the final results. All right, so it's been 24 hours and Propeller has processed all of the data. Let's take a quick look and see everything that they've given us. And then at the end, we'll look at the arrow points and compare the accuracy of the PPK corrections to our GNSS receiver. And this right here is the ortho image of our site. You can see highly detailed. That's coming out of the 20 megapixel camera from the Mavic 3 Enterprise. So lots of great detail here. And then we can also pitch this to see the 3D model. Now we did apply the filter to turn it into a terrain model. So all of the trees and man-made objects are going to be gone. And we're just gonna see what the bare earth looks like. But part of the bare earth is this hill. And that looks really good. I like how nice that is. If we go over to the survey tab, we can turn off these layers and turn on the point cloud and see what our point cloud looks like. You can increase and decrease the point size. I like to keep it at like 3. It just seems a little bit more full. You can just navigate through your point cloud to see the entire site. You can turn on the elevation map, which is like a DSM where you can see the high points and low points for your site. So again, the hill sticks out like a sore thumb. We see exactly where that hill is. The camera positions is simply going to show you where each of the images were taken with the drone. So this is just kind of nice to see relative to where the model is. If we turn on the gradient map, this can show us more of where the buildings are and other man-made objects. It shows us where things start to shift in elevation. So along the ditches here, we have the ditch along the bottom here. And I also have the contour lines on, so if I turn off the gradient map, it might be easier to see it with the ortho image. Yeah, so there you go. We can see the ortho lines. So you can see where all the lines come in, where they join. And then along the hill here, yep, you can see a major contour line. This is the 620 line. And so this is like really great. Like you can bring in all of the images and Propeller will do all of the QA/QC for you and then give you the outputs that you can use for stockpile reports, progress tracking, or even site collaboration, giving you a full set of tools that you can use for various types of projects. Now I wanted to go over the accuracy of the AeroPoint. If we go over to the top and select AeroPoints, and then we click on the 3 points that we processed for the site, here they are. We can click on this first arrow point, and here we have the geodetic coordinates as well as the state plane coordinates for our first arrow point. Now, we did use our IMLID GNSS receiver to capture the data. So looking here, it looks like our easting ends in 862.23, and on our GNSS receiver, 862.21. So that's 2/100ths of a foot. I like it. Northing, the arrow point ends with 835.27. Here we've got 835.24. So around 3/100ths of a foot. That's also really good. And then the elevation, the arrow point is at 613.77. And our GNSS receiver gave us 613.79. So that's 2/100ths of a foot. So very, very good, very impressed. The coordinates are coming in accurately compared to our GNSS receiver. Let's look at another point. This is arrow point 2. And here we've got the easting ends with 620.78. And we have 620.79, 100th of a foot. Arrow point 185.12. Here we have 185.12. The northing is right on. And then the elevation, 614.34. Here we have 614.35, 100th of a foot. Awesome, I love it. And again, for those metric viewers, 100th of a foot is equivalent to 3 millimeters, 200th is 6 millimeters, and 3/100ths of a foot is typically 1 centimeter. All right, let's do the third arrow point. And it looks like we've got 634.34, and then we got 634.37, so about 3/100ths of a foot in the easting. Arrow point 709.15, and then we've got 709.15 on the IMLID, right on in the northing. And then final elevation for the arrow point, 614.596, and we've got 614.597, 1,000th of a foot. It's right on. So I love it. The arrow points PPK corrections are coming in precisely the same as our RTK measurements with our GNSS receiver.
Now, one other thing we can do is duplicate our control and process it using the Propeller correction network. I'm going to set the datum here to NAD83, and we are going to start processing, and we'll come back once the corrections are ready. And now that the processing is complete, you can see here we have a copy of our AeroPoints project, and this was processed using the Propeller network correction. And if we look at the easting here, ending in 862.20, we have 862.21, which is 1/100th of a foot compared to the GNSS receiver. And in the northing, 835.31, we have 835.24, 7/100ths of a foot. And in the elevation, 613.68, we have 613.79. So that's about 1/10 of a foot. Over on point number 2, we have 620.76, 620.79, so that's 3/100ths of a foot, 185.16, 185.12, that's about 4/100ths of a foot, and then 614.25, 614.35, so again, about 1/10 of a foot in the elevation. And then the last and final point 3, 634.30, 634.37, so 7/100ths of a foot, 709.18, 709.15, so 3/100ths of a foot again. And then in the elevation, 614.50, and on the GNSS receiver, we had 614.60. So again, about 1/10 of a foot in the elevations when you use the Propeller network corrections.
Overall, if you're looking to simplify your field procedure using AeroPoints, I highly encourage you to check out the Propeller ecosystem. From data collection to data processing and QA/QC, they've got you covered in delivering high accuracy survey data. Special thanks to Propeller for sponsoring today's video. If you guys would like to learn more about surveying, then check out thesurveyschool.com, where we offer premium courses and coaching calls to help elevate your survey knowledge. Thanks guys for watching, and I'll see you all next time.